Welcome everybody to Office Hours. It's that time of the month again. As always, thank you for giving up your time. We very much appreciate it. Oracle people, we get paid to do this, but you're giving up your precious time, so thank you as always. Huge bumper session today, so I want to very quickly run through some slides. We'll get into it because the less time I spend doing intro, the more time we can actually get into the nuts and bolts. So let me share my screen. Once again, as always, sing out on the chat line if you can't hear us or see us or anything like that. Let me just drag this up like that. But let me get into it. I'm going to spend as little time as possible. Getting in touch with me is very, very easy. Scan the QR code or head over to linktree/Connor or hit me up on Twitter. My DMs are always open. Always like talking about tech. Couple of bits and pieces before we get into the show. Some things that I always like to share. Number one, 23 Database AI is available now. So you can download the free version to play with it, see all the cool features. You can also get it as a base database service now on our Oracle Cloud. So if you want to run the base sort of typical VM, you can run that now as well. You can run the autonomous free version as well. And if you're an Exadata customer or recently an ODA, an Oracle Data Appliance customer, you can also run 23 AI. I think we're up to about cut 23.6 there, ready for you to use. A couple of things coming up in the next month. I'll be in Doag for the Doag conference, a massive event in Germany. So if you're anywhere in Europe and you're near Nuremberg, please get along to the Doag event. There's normally several thousand people there. Fantastic event. And shortly after that, we have the UK Oracle User Group. My first ever user group speech overseas was at the UK User Group in 1999, so holds a special place in my heart. Unfortunately, I can't get there this year due to a collision of some other events, but I hope to see you there if you're based in England. It's back in Birmingham, the logical home of the UK Oracle User Group. And as I always say, support your Oracle local user groups. They had a hard time during COVID. I've just been back from the EMEA tour and there's a real buzz in the air at user groups now. So really thrilled to have that back and hopefully we can keep growing that energy globally. Tonight, you're not going to hear too much of me, which I imagine you'll be thankful for. We have a very special session. When it comes to a powerhouse of Oracle knowledge floating around, rest assured we've assembled some of the greats. So I don't want to waste time giving you an in-depth bio of each of our speakers because that just burns up time that you would rather have digging deep into the tech content. So literally, that is the end of my slides. I know our first speaker tonight is Barry McGillen. So I'm going to stop my share, I'm going to stop my video, and I'm going to hand over straight to Barry, and he's going to launch us into a very, very special Office Hours session. Enjoy.
We are going to talk today about one of the biggest challenges that everyone who has worked in database, since for as long as Connor has, since 1999 or before, like some of the rest of us, we're going to talk about some of the biggest things that happen after you've created your tables and after you've created your procedures and functions and all of those things that go into your application for those things. We are going to talk about application deployment and how that actually is difficult, even though it sounds like it's simple, but it is difficult and it is error prone. And we're going to take a look at that today and talk about what tools we're building and process we're building and rolling out today to show you how to do that today. So between us all, there is myself. I'm going to intro this today, and we also have Dan, Martin, and Neil, who will do the deep dive into the details of what's in these projects and talk about then the demo of what's going to happen. So Martin and Neil then will come along and do a demo, and I'll circle back at the end, tell you about what you just saw and where you can get help as you try this stuff out, and maybe take a look at some of the development team as well. Okay, let's see. Now, okay, why is CI/CD so hard for all of these things? Well, for me, the biggest part of this is that all of the things that you can do in a database is pretty much there. You can run SQL Plus, you can run SQL Developer, you can go and make a change and change it out. There are no standards for any processes that are there. Yes, there are tools, and we'll talk about some of those in a minute, but most of those do not do anything more than atomic changes or things that you can use to generate into your scripts. And the most things that that people are talking about, especially in production systems and especially in high-level systems and high-risk deployments. You want to know that high risk means that you need clarity of what's going to change, and you need a surety of that it's going to be successful. And that's what we're going to talk about today, is to see, can we generate a process and can we generate some tooling that will help automate a lot of the issues that are there today. So let's talk a little bit about those. So what is there today? Well, there are a lot of things, but specifically, and the ones I want to talk about today are Liquibase and Flyway, that talk about database changes in a way that are very similar in a way. Liquibase talks about changes that are that you wrap up into a change set and a change log, and you run those on your system. And then any audit trails are kept in tables in the database, and you can apply those so that the next time you add something, that it checks against what has been run already and goes to go and run that. Now, the downsides of those are Liquibase runs what it's told. You give it a script, you give it a set of changes, it's going to go try run those, and it works on sets of checksums to say, okay, have I run this before or not? So it's kind of a clunky in some ways in terms of figuring out what changes actually need to happen. Flyway is similar, maybe not as advanced as Liquibase, and they have ways of literally calling out the versions of the SQL that they're going to run for those things. Now, Oracle has pinned its hat around Liquibase, but we've taken a little step further than that, and we've extended Liquibase support to support Oracle scripts and Application Express exports and ORDS modules and permissions. So those would be the main ones that we're seeing around there, apart from things like scripts and pipelines that are held together with those types of things. And we're hoping to change that by introducing some extra things into SQLcl. So what is SQLcl? For those of you who are working with SQLcl today, forgive me, I'm going to blow our trumpet a little bit. SQLcl is a tool that is built on Oracle SQL Developer and has grown immensely over the last several years, with millions of users on multiple platforms across the world. So the main thing for me is about SQLcl is the ease of connectivity that you can have to an Oracle database. And moreover than that, specifically for this audience, is that it's easy to use and it's a lightweight install, i.e. that you can install it from OTN, but more importantly, you can install it from Yum or download a Docker image, or even on your Mac, do Homebrew, or Windows, use Chocolatey for any of these things. It is available. Go use it. And that's one of our biggest things, is to put tools in front of you. I have my little wrench over here on the right-hand side to say we are building tools for developers to use, and at the end of the day, that's what we're doing, enabling developers for those. Now, there are multiple features, and we can talk about those all the way through to make developers more productive in their day. And again, the bit we're going to focus on, and we're going to talk a little bit more about in the next 20 minutes, and the guys will demo to, is about our extended Liquibase support that we are announcing today, that we're building on top of that Liquibase support to provide a feature that we're calling SQLcl Projects, that will encapsulate changes that you can create in the database and changes that you can apply to your production systems. So we're going to introduce SQLcl Projects. And what is it, right? We talked about the problems a minute ago, and really what we want to do is to define a prescribed process for database developers to work in their database, create their tables, create their objects, and then be able to export those into a file system where they can put them into a source control system. And we're banking on Git with this, and that's where our demos are talked about today. But more than that, not just exporting your objects out in a standard form, we're going to define a file structure that we think helps the users to identify what they've exported from their database against what they are actually going to create to deploy to their test and production systems. So we will generate one folder for source and another folder for the actual changes that will get applied to the databases. And both of those are in sync and will be kept in Git. Thirdly, the other thing that we're creating are tools, tools for generating the exports, for generating the changes, for generating artifacts and those things. That's what we're aiming to do to allow you to do these things simply and then automate those inside in your pipelines. So finally, we're going to generate an artifact of all of the changes that we want to make and then wrap that up so it's nice and flexible and you can go and deploy that to your system as you go. Okay, I'm going to switch to white for a minute because my super slides didn't like dark mode. So I'm going to give you an idea of at a very high level of what the actual tooling will do for your project. So as I say, this is our CI/CD that starts off with project creation. In project creation, we're going to init a project either in your existing source control that you have set up already, or you can go and create your new repository and add this set of files into it. And this will add the files that make up the project, including a lot of our configuration for exports and changes and artifacts and that type of thing. And once you have that in place, you can go ahead and you can go export your full schema or multiple schemas or whatever it is. And you can control all of that with filters in the configuration to identify the types of objects you want, the schemas where you want them, or even the types of ways that you want it exported. So for example, you can use DBMS metadata transform options to use schemas or no schemas or get rid of storage clauses and all of those normal things that will be generated by DBMS metadata. And that all gets exported out onto our known file paths. Once that is checked in, again, we can come along and we can compare what was originally in source control against the branch that we've created for the database export. And we will compare those things. And we essentially do a git diff on the initial project with nothing in it against the one with the export. And we come up with a list of git diffs. And using those diffs, we will generate the alter statements that take you from one object state to another, or the creates, or the any of the pieces of SQL that need to be generated that bring you from one project state to the other. And all of that get generated in another part of our prescribed file structure called dist, which Dan will talk about shortly. Okay, once the changes are there, we create, or we allow you to create what's called a release, and that gathers up a bunch of the changes that you've staged and wraps them up as a nice release. Call it 1.0, 2.0, whatever it is for you. And using that, you can then generate an artifact which will zip up all of the changes for your release, and it will apply and install SQL on the top of that so that you can take this artifact, either put it in Artifactory or on your file system or wherever it is that you want to put it. And then you can go and take that and deploy it, either in test to go and make sure that things are actually working before you need the surety of where you're going. And then once you're happy with all that, install that into production. So without further ado, I'm going to say that's all great. But now, how does it work, Dan?
Before I dive in, I need to define a few terms you might hear me use a little bit. When I say soft object, I'm really referring to things that have create or replace syntax. These are really easy to work with. You want to get the latest thing out into production, you just drop it in and compile it. When I say hard object, I'm talking about things like tables and their ref constraints and indexes and so on. These are more difficult to work with because data is in the mix and we can't lose our data or corrupt it. So we have to use more care when we're evolving those types of objects. I'm going to do this in two parts. First, I want to talk about the source control repository. We'll do a deeper dive. And then I want to talk about the process we use and how it all works together. This is a typical SQLcl project directory structure, high level anyway. We have this DB tools directory here where you're going to find some config related to the project. Of course, we rely on Git, so you're going to have a Git directory as well. And then we have both source and dist. And this is one of the things that really makes the SQLcl project approach different. I often see projects and teams that are working with things where you have one of these, but not both, at least not in the way that we use these. So let me talk about that. We'll start with source. You can think of source as essentially just an export of all your database objects. This is a representation of a particular point in time of your database. And this is really useful when you want to track evolution of a given object, right? It's laid out like source, database, schema name, object type, and then you have your files for different objects. So you can find your object, you can see how it's evolved over time with Git. And it's also very useful when you're working with a lot of code objects. So things like packages, views, triggers, if you want to use that files first approach where you find the file in your directory structure, compile that in the database with your favorite tool like SQLcl, the SQL developer extension for SQLcl, or rather for VS Code or SQL Dev, you can use whatever you like. That's another really good use case for that directory over there. And then we have dist. And this is just an immutable ordered set of SQL statements that essentially arrive at the state of source. And so these two are kept in sync. And this one's really useful because it's going to provide complete control over how you evolve your schema over time. It's just one SQL statement after another, and that doesn't change once you get merged. And what's nice about this is that every object is versioned in such a way that in the future, if you were to change something, you're not going to break any historical custom SQL. You're only dealing with things moving forward into the future. So let's take a closer look with an example. Here, imagine we're starting a new project. So we've edited that project and we're getting started. And luckily, it's a really simple application. We just have a single table with a few columns. And in the beginning, both source and dist are going to look very much the same because the export of the table is the create table statement. And what we need to deploy that in different environments is the same statement. It's really when we get to version 2 that you start to see the differences between these two directories. So source is going to tell us what's changed, who changed it, that kind of stuff. That's great. And again, allow you to compile in the code objects nice and easy. But dist is a little different, right? I can't just come into this create table statement that was run before, add that new column. That's not going to work, right? What we need is an alter statement. So that's the kind of thing you're going to find under dist. Now with V3 of our application, we found that first and last names weren't working out. We have employees with 3, 4, and 5 names. So we're going to consolidate to a single name column. So you can see what that looks like on the left. You can understand the change that's happening rather easily. But then on the right, of course, we need these alters, right? We're going to create the column, then we're going to drop the old ones. Now, if you've been doing this type of work for a while, you probably spotted something missing, right? We need that update statement to transfer the data that's currently in the old columns to the new one prior to dropping those old columns. And this is what I mean by everything gets versioned, right? This update statement, once we drop that in, it's going to work forever because we're just going to be replaying these things over time. And another nice thing about that is these installers that we end up with can take you from 0 to any version going to current. And so it's a really nice system that you can use to, if you have customers on different versions of your stuff, it doesn't matter. It'll get them to current without any issues. So far, when we look at dist, it kind of looks like a single file in there. But in reality, it wouldn't work very well, especially when you're working with lots of code objects, packages, and so on. So what we do is we break that up into different files. And we use a hierarchical changelog system, as Barry noted earlier. Change logs and change sets are liquid-based terms. I tend to think of change logs like ordering SQL and change sets as SQL. Maybe that's not an exact definition, but that's how I tend to think about it. And the way we do it in SQLcl Projects is we start with what we call the next release. And this is just a representation of the current sprint you're working on. And so in this particular release, you're going to start to collect changes. And eventually, at first, right, there's no changes in a release. Everyone's kind of working on tickets, but somebody's got to get that first merge into main. And when that happens, you'll have this first change in your next release. And this particular change just has 2 SQL statements. So nice and simple so far. The next merge comes in, and all of a sudden that's the second change in your release. It has a single SQL statement. But now you start to see what's happening. These things are just going to be ordered over time, and they're never going to change. And so when you're done, you can cut a release. And what that does is it takes what was previously called next and renames it to your release, and then creates a new folder called next and allows you to continue the process, right? Here's the first change in our next release with 3 SQL statements. We're up to 6 now. And it's just rinse and repeat, right? Cut a release, make some changes, cut a release, make some changes, and you just keep going. All right, let's dive into the process. And I want to talk about this in the context of the example I just gave you. So we'll walk through the V1 to V2 change from before. So we got to add that dep no column that was missing in the original deployment. So in V2, the first thing we need to do is make our changes in the dev DB. And frankly, we don't care how you get that done. We're agnostic. If you want to use a shared dev database, that's fine. Or you can use an individual one. You can do files first development or work directly in the database. You can use a code generator. You can use a GUI. You can write lovingly hand-coded SQL. We don't care. Just get the work done and then move on to step 2. So in step 2, we're going to have you sync the repo with those changes you made in the database. Now, if you just change the soft object, then there's really nothing to do. If you went into the repo, compiled that in, the state of what's in the repo and the database is the same. But if you modified any hard objects, we do need you to export those out. And so there's an example command here. This is project export, and I'm using the object flag to grab the employee table. And now I can see my diff over here. Things are looking good. So I'm able to move on to step 3. In step 3, I'm going to need to generate these liquid-based change logs and change sets. And for that, we have the project stage command. The project stage command is kind of where the magic happens. So basically, this command is going to look at your current feature branch where you're ahead of where you started, right? You probably started from main, you branched off of main. And what we're going to do is we're going to compare back to main. So we're going to look at this file in 2 different points in time, and we're going to see what changed. And then we're going to generate the alter statements necessary to go from the previous state to the new state. We're going to package all that up and all those the change log hierarchy I described before. We're going to do all that heavy lifting for you. We found that it gets most developers 90+% there. And then they often just have to do a little additional work, right? So I mentioned that custom SQL statement before, the update. So that's the kind of thing where you would use add custom. So if you have to add any custom SQL, you can just run that command there. It'll create a new file. It'll link it into the changelog. And then you can just put whatever SQL you want, move it in the correct order of operations, and then you're done. Once you've finished with that, you can go ahead and test everything on a test database. For this, we have a few different commands that might be relevant. Project verify can run some sanity checks to make sure the repo is in good order. There's gen artifact, which will create an artifact which you can then use with deploy to get those changes into your test DB. And then finally, you're good to merge your changes into the repo. Now, the last thing I'll say on this is that we are not asking anybody here to be guinea pigs, right? Although this tooling is new to the public, we've been using this process and related tooling internally at Oracle for nearly 2 years and on a variety of projects. It's worked very well. The rate of success, our error rates have gone down, quality's gone up, everything's working a lot better. So I know if you give it a shot, it's going to work well for you too. Thanks. Martin, can you give us a demo?
We're going to show this in the real world. So what I'm showing you is the current active version of SQLcl Projects. And before I begin, I'm showing my VS Code editor so that you can see the files, the path, and the terminal. So this is SQLcl. Here, I've already fired it up. Here is the folder that I've created called Demo Project, and that's where all my files are going to go. And at the top, sometimes I'm going to open a file to show you what it looks like. And that's what it is there. So it's one screen, we can do it all. For the demo, what we're going to do is first set up the project. You're going to set up a Git repository. Oh, my camera's not on. We'll set up a Git repository and initialize SQLcl projects. And then what we're going to do is simulate a sprint. And normally a sprint, we do a release after, and a sprint consists of multiple tickets. In this case, we're going to do 2 tickets. And the two we're going to split out those tickets between 2 different developers. So the first ticket is to create a table called 2 tables emp and dep, add some data. And then the second ticket, we're going to actually alter the table and add a function. And these are very common things, very simple tasks, but to get it actually and release it in order, in the proper order, can be complicated. And this is what we're going to show is how SQLcl Projects manages all of it. So to start, we're going to git init a project, and this can be almost a clone of a Git repo, entirely up to you, but we're just going to use local Git repositories. The next thing we're going to do is project init. And this is, you only have to do this once throughout the whole history of your project. And if you miss anything in here, you can always modify it after. I'll show you that why after. But just by calling this, you get a bunch of folders here. Source, as Dan said, this is almost like a replication of your database source, right? So it should be one-to-one almost. And dist is, again, what gets installed into your other databases as it moves from dev to test to prod. And DB tools is a bunch of configuration content here. So the first thing I'm going to do is just open the project configuration, and I'm not going to go over it, but there's a lot of different configuration options you can use. And you can read the documentation for more information. But again, if you forget this in project init, you can come back and modify anything here. And so now that we've got all the scaffolding in place, I'm just going to do git commit. I'm going to add it. And throughout this demo, you're going to constantly see us do git commit or git add, git commit. And that's just to simulate what a real world project is, that you do some work, you commit it, you do some more work, you do commit it. So now I'm going to work on my first ticket. And the first ticket, I'm going to create a git branch, and then I'm actually going to create the table and add some data to it. So I've created my branch, and now here I've already got create table scripts. We're not going to actually show them. They're just create table and add an index. And now that it's in this database, right, and I could have done that in SQLcl, SQL Developer, or even in Apex SQL Workshop, I'm now going to do project export. And what project export does is it goes into the database and takes all the database objects and moves it into the source folder. You can see that as I added it, everything that I ran before, index, table, ref constraints, they're all added in here. So if I open the emp table, you can see it's just the exact statement that I ran to create the emp table. And now that I've got that in source, right, this is, again, replicating what the database has. I'm just going to add these, commit them. This is very normal Git task that you would do. So now that I've got them in source, how do I kind of set it up to be released, right? And we have to be cautious about this because I can't start indexes, or I can't create indexes and foreign keys before the tables are created. So there is an order of operations. Normally, this is where things go wrong in deployments. And what we've got is this new command called project stage. And it's really good because you'll see it orders and manages everything for your deployment. So I'm going to go and investigate what actually happened. So project stage created this thing called, and this is now Liquibase, but Liquibase XML, that before you had to do a lot of work to manage, but now we can do it for you. And so this first thing is the main changelog, and that's what really kicks off the installer. And then you're going to see it reference next.release changelog. Now, the word next here is our active sprint that we're working on for development. As this goes on through time, you'll see a lot of these saying version 1, version 2, version 3, etc. So I'm going to go into next and go into release changelog. And in here, it's got, again, some XML, and it says, okay, we've only got one ticket so far. And so we're going to go into that ticket and run the stage changelog. In here, this is where, again, some of the magic happens. SQLcl Projects knows that tables have to be created before constraints and indexes. And so it puts it all in the correct order. Now, the nice thing is if you're not happy with this or you see a problem, you can always move these around, but we try and do it for you in the best possible order. And so then if we just drill down into here, it's going to say, okay, run the dep, run the demo is our schema name, find the department.sql, and this is the actual SQL it should run. It adds some Liquibase formatted SQL here. You didn't have to do anything. Everything I'm showing you is exactly what you get in SQLcl Projects. So now that we've seen it all, we're just going to add all these files into Git. And so now they're committed. The next thing I want to do is add some data. And the reason why we're demoing this is the concept of custom files. Now, the reason why you'd want a custom file is if you want to run some anonymous block of PL/SQL or custom DDL that we don't cover, or some DML, in this case, dep and emp data. So what it will do is it will create two files, and you're going to see them show up here. And it just adds all the liquid-based formatted SQL. Again, this is the stuff that people get confused about. What do you put in all this? You don't have to worry. And from here, you can actually just enter in the SQL you want, or the anonymous block of PL/SQL. And so to speed things up, I'm just going to inject each one of these files with the correct insert statements. Normally, you'd have this file open, let's say, again, in SQL Developer or VS Code, typing it, running it, committing it, testing it, maybe rolling it back until you get it to the version you'd like. So I've got them in there. And now, just because I automated that to inject it into the file, I'm just going to run these two files in my dev system just to show you that they're standard insert statements. So again, I'm going to add and commit to all this. And there is one small thing I do want to show before there is by adding the custom file, again, we included it in our change log. So we said, this is where it's going to be referenced, and this is the order we think it's going to be, or we think you should run it in. Again, if this block needed to happen before, you would just move this line up, and that changes the order of operations as you deploy to another system. So now that I've committed it all, I'm finished my work. I had two main tasks: create the tables and add the data. And I'm going to merge this back into main. Now, in some of our docs, we show these as local merges because we're just running a local Git repository. But if you use GitHub or GitLab, this is a pull or merge request that's commonly referred to as. And now I'm done my ticket. So I'm going to go hand this over to Neil, and he's the second developer on the project, and he's going to work on his ticket and show how he picks up from my work.
All right, so I'm going to be working on ticket 2 today. So my 2 tasks I have are to create a column called email on the emp table, and then I'm going to also add a new function. So first thing I have to do is I am on the main branch. So I'm going to go ahead and check out my ticket branch. I'm going to go ahead and alter the table. Again, this statement here, it's choose your tool, SQLcl, SQL Developer, run your DDL. It's not in my repo, right? I'm just running this straight on the database. So one thing I want to talk about here is that after I ran it, the next step I'm doing is now to get that into our source control, I have to export the table, right? And doing so, there's a argument, the -o argument, and this allows you to specify an object that you want to export. And you just have to give object name. It doesn't matter the type, it'll find it and it'll export it. And any dependencies as well. So foreign keys, ref constraints, etc. It'll pull them out. So right now I'm exporting the table that I modified rather than the whole schema. And here we have my table. It pulled the ref constraint, pulled the index. And let's go next. I'm going to go ahead and take a look what we got out of that, right? So here is the emp table now. You're going to see the new column here, email. If I look at my changes in source control, this got added. As Martin noted before, we have a target database that may have this already. So we can't simply just deploy a create table statement again, right? So we're going to come back to that. Let's go ahead and add and commit my changes. So I'm on ticket 2. I added, I committed. Martin explained the stage command. So this is the part where the magic happens, right? I didn't track that I did an alter table statement. Right now in my file system, I just have the source code that says, here's a table, here's the full definition of it. But to get that change over, I need the alter table statement. So when I run the stage command, it's going to produce that for me. It connects, it does a diff, it's looking at Git to do the delta comparison and generate all my corresponding liquid-based change logs, change sets, so I don't have to worry about it. But it does give me an opportunity now to review it. So if I take a look at the file that was produced, here, this is produced for me, and there's my alter statement. So you have a chance to intervene, take a look, make sure everything's correct. I'm happy with it. I'm going to go ahead and add all the files, commit them. And next thing I'm going to do is I'm going to create a function called get display name. I'm not showing the meat and potatoes of the function, just the top of it. And after I create it, now I need to get that change out, right? So I never put this function in my source control. I just ran a create or replace function in the database. So now you see there's no function, and there we go with project export. It goes ahead, it pulled out the whole schema, but I only modified one thing since my last commit, and that was the function, and there's my delta. So if I take a look here, there's the function I created. It got exported for me. And I'm going to go ahead and add this file and commit it. My source control is all up to date. Right now, my distributable has my alter statements that will get deployed, but it doesn't have this function. So I'm going to go ahead and run stage command again. I need to get this change to be deployed. I went ahead, I ran project stage. And if I take a look now, there's a few new files, and you're going to see here inside of the dist folder, for our next deployment, we will get that function deployed. And this is done through a series of looking at checksums, comparing the master branch. It didn't have the function, it knows it needs to create it. So it's pulling it from source, dropping it in. It's essentially moving it over, right? So let's go ahead and add and commit all my changes. Great, my ticket has all my commits done. And now I'm done with my changes. So typically what would happen next, as Martin was talking about, we'll merge this back into our main line, and depending on your tool, merge request, pull request, name your terminology. I'm just doing a merge directly to that line, assuming it was approved. Martin's happy with it. There we go. So now we're on the main line. This has all the working changes. We're assuming we tested them out already. I know Dan mentioned a test DB in this example. We're skipping that piece. We're going to assume everything was tested fine, and we're going to work on cutting a release next, generating an artifact, bundling it up, and then taking that artifact and deploying it to a production instance. First step is to cut a release. So I'm happy with all my changes. If I collapse this, I have my source, I have my dist. We vetted that everything in dist, we ran it somewhere, it works, we like it. And we said all the changes in next, they're valid, they work on the upgrade, on the install. Let's go ahead and bundle it up and tag this as a release. So there's a parameter version. I'm naming this release 1.0.0. And what this essentially does is it moves everything that was in that next folder into releases 1.0.0, right? That's like tagging it essentially, right? So the bucket next of all the next work that's going to be started on is cleared out, ready for work to happen. And you can see here 1.0.0, it just moved everything over. And next is empty. So that's the release process. I'm happy with it. We're adding everything to Git. We're going to commit it. And now we're ready to create an artifact. And this is going to be a zip. And we're gonna use this to hand off to a team to be deployed, that team being me for this demo. And let's generate the artifact. So we now have a artifact folder you see here with this. This is the distributable. This is the distributable zipped up, ready to go to hand off to be consumed by SQLcl to go ahead and deploy. You will notice that it is grayed out. It's not tracked in Git, right? We already have dist in Git. This artifact does not need to be in Git. You decide where you want to put that. It is Git ignored by default. I did want to point that out. Now I'm going to deploy this to production. If I scroll up, so there's a deploy command. It popped up and went. I'm connecting to our production instance, and I'm simply putting project deploy and the file. This file could be somewhere remotely. For me, it's locally, so I specified the path. And it went ahead and took that zip, and I'm gonna type it out at the end because it flew through it, and now my screen's cleared. But it ran the install. It took the zip, opened it up, and deployed it. And you can see all our changes here. Here are Martin's changes from ticket 1, and here are my changes for my second ticket. I have the modification on the table, and I also have the display name function. So 8 things were ran, no errors, deployed successfully. Migration has been complete. And that's it. So yeah, thank you everyone for your time. And on that note, I will hand it back off to Barry.
Okay, thanks, Neil, for that. So, what did we see? We saw a lot of stuff here today for SQLcl projects, but at the very start, we were looking at a process of creating any sort of objects and exporting those out in various different ways. And what we're doing today is we've defined a process for capturing and curating changes in the database using developer check-ins. Now, I see in some of the questions that some people are talking about that they work in files and want to check into that way as well. And we'll certainly deal with that. It's something I need to write up something on in terms of when you are creating files, that's how you get the liquid-based changes in there. So we have a process for this, and we have a framework, essentially a plumbing system of wiring all of these things together so that you don't have to do this yourself. So any of the liquid-based changes and stuff that we are generating, we are wiring them all up together. So any of the tickets that Neil and Martin showed, they are dropped into the framework. All of the controllers are all updated in the sets, and then you can order those as you like. So depending on the tickets and what you're doing, there's nothing to stop you going in to edit those and change the order of what you want to do there either. Finally, then we can come along and add custom changes. So there's other questions there today about, if I have blobs, if I have something, if I have data I need to play with, what do you need to do? Then for us, we're going to generate some custom changes there for you to literally create a box that you can go play in and do whatever you need to do for your system. And then you'll see in the order that you want, we'll play that in the same way. So that allows you to make use of all of our automation and all of our generational capabilities, and then put your custom changes on it. And once all of that's done, as Neil showed, you can cut releases with that known set of changes and wrap them up into an artifact like a zip file that can then be deployed either in test or in production once you've that verified. And even when you're working through your tickets, you can always run that install.sql at any time to check the validity of what you have created as part of your ticket before that gets added into a release. Okay, that's where we are today, and there's a lot to do in terms of all of the various different things that we're seeing. And we're hoping that as we show this to you, that you're going to have various different ways that you like to do it. And we'd love for you to come and feedback to us what you see and what you like, and also what's clunky for you in terms of this release and what you'd like to see. Okay, how do we make that easier? Working with files is probably one of those that I want to tackle with soon. But in the very near future, we have a very clear plan. First of all, it's more object support. So all of the standard objects are supported today, but we need to add support for things like schedulers and queues and other different objects that take a different treatment than what DBMS metadata will do for those. And obviously, we also need to add a bunch more use cases in terms of how do I integrate this into existing projects. So if I've got a project that I have been working on for several years with a load of history on that, am I able to map that project into our current scheme, or vice versa? Will we be able to do map SQLcl to a current existing project? And those are things that we have enhancement requests for, and we need to talk about how we want to do that moving forward. And finally, and I think this is where it's going to be of most use, is when we integrate this properly into SQL Developer extension for VS Code, where you will be able to export your code or commit those from SQL Developer inside VS Code as well. And again, all of our demos are shown in VS Code, as it's a very nice, seamless way to go through these things. So when you get this, how do you get support? Well, if you've got a support contract, obviously you can go and log an SR. And for us, for most of our support from people who are using this, we are opening up the forum and SQLcl to go and talk about SQLcl. So you can come along and ask about CI/CD and tag it with that, and we will answer your questions. So all of the guys on here will answer your questions. And I'm sure as the community gets bigger and more knowledge around this, these will get better as well. So when you download it, go play with it, and we will see you on the forums. Okay, finally, what I wanted to do was to give a shout out to the developer team, because it's more than just us on the team. And there's more than just people in one area. The team here today is built around a lot of very good developers who are all over the world in various countries. So various countries, various time zones, all working in unison for that. So I want to give a shout out to everyone on the team, including those that have not mentioned. Sorry, Jeff, I missed you. And see where that is. So when you're using it, give a shout out to any of the guys that you see on social media as well. This is their success as well. And we'd love to see what you're able to do with it. So we can take questions.
Yeah, I'll just jump in for 1 second there. For those that might have missed it on the call, you might be thinking, okay, so that's all great. When's this actually going to be available? Well, let's have a little look-see. You can literally go get it today. So SQLcl 24.3 has come out literally almost as we speak, almost during this call. That's got the first iteration of the project command in there. As the guys have said, we're continually working to evolve this. But yeah, you can literally go get this today, start playing with it, start exploring with it, jump onto the forums, etc. So be aware it's not some future tech that's going to come in the new year. Basically, the infancy of it is there now, ready for you to use and play and explore. And obviously, it will continue to iterate and get better and better, mainly based on your feedback. So the more you can feedback to us, obviously the more robust and absolutely more quality we can put in there and cater to all your particular circumstances, scenarios, etc. Because the more you give us to us, the more we can actually make the tool prosper for everyone. So let me just stop that share. We got 10 minutes left. So once again, I'll hand it over to the guys. They can tackle any of the Q&A. There's still plenty of questions out there. But yeah, if you have any questions or thoughts or comments, throw them in the chat line of the Q&A. And we've got 10 minutes left to literally give you as much help as we can for this new awesomely cool product.
So does anyone have any new questions that they want to talk about? We can go through the questions that people have already asked. I think I touched on a few of those. One of those was about when you're working with files, what is the process for that? Which we would recommend that you can work in files and then put it in the database and export it out again, which will automatically generate the SXML tags for you. And that's certainly one of those questions. Another one that I've seen is certainly for people that have a different project structure than the one that we're prescribing. And that's certainly something that if you want to maintain that, we do have tickets to map your existing structures into our prescribed projects as well. So there will be that, but it's not there yet. Does anyone else have any that they see pointing out?
Barry, I just wanted to make a quick comment. I've seen a variety of questions that are touching on a similar topic about working in shared development environments. And, there's this common situation where people are stepping on each other's toes, and we get that. I can't say a lot, but I will say that we're working on a solution for that too. We have again, internal tooling that we've been using for nearly 2 years. It's been working great. And we're working on a version of that we hope to get out to the public. Attend the Apex office hours session that's due in about 2 weeks. And perhaps I could tell you a little bit more about that then. So the question that came in, go ahead, Martin.
Oh yeah, about Apex app developments and deployments. And yeah, we'll show that a bit more in the Apex office hours. It will be very similar to this, but overall there's a filters in the DB tools folder. There's a filters, and you would essentially just append your application IDs. So if you have 3 applications, application 100, 200, and 300, you just put 100, 200, 300, and then it will automatically get added as part of the release process.
And to the more generic question, does this work for Apex app deployment? Absolutely. We've been doing that for quite some time. It works great.
So someone asked it was an excellent question about liquid-based rollback. So liquid-based rollback is not database rollback. Database rollback handles DML. So if you insert a couple of rows and you want to undo that change, you write rollback. A liquid-based rollback is if you create a table, alter a table, and then something breaks, you go back to the original state. We're not supporting that because it is actually very complicated to write a proper release rollback. And so what we're using is a concept called roll forward, so that when you do encounter an error, you need to stop and resolve it. That said, setting up good testing systems will really make a big difference. If you're on OCI with ADB, you can set up clones very easily, test, throw away the clone. There's lots of different processes to do that. That said, we're going to be looking at documenting some of those processes to help everyone who doesn't have that skill set to start. We want to document it so that you'll know the path on how to properly test your releases.
I'll just add to that rollback is the liquid-based rollback is in my opinion, it's not even worth playing with. It's only going to work in a dev environment. You don't want to spend time trying to make that work. Oracle database has restore that actually does work. And so depending on your scenario, you could roll forward, as Martin suggested, and in some situations, that's the only option. But if, say, you're in a dedicated database that just is running one project and you can take some downtime, you might just kind of take a timestamp when you start a deployment. Anything goes wrong, you might say, you know what, we'll just restore and we're back to where we started. We'll figure out what went wrong and give it another shot later in the future. But that's using Oracle Restore.
Just on that topic, just to let people know that one of the things I cannot recommend highly enough is Flashback Database. And not necessarily, people talk about Flashback Database in terms of something I would use in production. It's a great thing to use in your test and dev environments. Literally build a little API which lets your developers take a restore point, which is instantaneous. They can play around, they can do all sorts of damage to the database. And then if they go, oh, look, this hasn't really worked out the way we wanted, you can literally flash back to that restore point, and it's incredibly fast no matter how big your database is, because we're simply rewinding things. So Flashback Database. One of the questions someone asked about using EBR, that's also another way of avoiding having to roll back. You basically push things into a new edition, and if things go wrong, you simply delete, throw away the edition, and you haven't, once again, damaged the existing edition. In terms of, someone asked a question about supporting editions in this kind of framework, don't forget custom SQLs can do anything like alter session to set a current edition. And even if you had none of that in your actual Liquibase or repository there, simply connecting to an appropriate database service can actually bind you to a certain edition. So even if you had none of this support, you could do it outside the tool simply by connecting to appropriate services.
I will just underscore all of that and just say the tools. Sorry, Neil, we'll get you in.
You're okay, no worries.
That all of this and the tooling that we're talking about today is about creating immutable objects or artifacts that you can test, and retest before you take it to production. Because especially in high-risk stuff that we talked about earlier, you want to know that something's going to go and it's going to install, and you have the confidence that it will work when you take it to production. So, for those things, yes, talking from Martin, yes, you can. Our process is to roll forward, but I would hope that that is worst case scenario for those, that you would know that where it is before you get there.
And I just wanted to touch on Vito's question, which I think is going to be a common one, about any experience using this on existing projects, right? Because I'm sure there's a lot of existing projects that you will want to convert over. And there will be a more guided instructions on how to do so. I believe we have some out right now. But when it comes to upgrading an existing project, the premise is that you have a production database already with the objects, right? So you can't simply run create. If you start using this tool, it has, create table XYZ, you run it, it never used Liquibase before, it can try to create the tables, you're gonna have problems, right? So we have instructions on how to get the changelog sync and pretty much imitate, that we're up to speed and now we can start using this framework. So yes, we have used it on existing projects, Liquibase and tooling like this. So the instructions in the docs will give you a guide for that.
There's a question that came in the queue. Barry, you can actually speak to this better than I can about deployment options when it comes to pipelines further downstream. Would you run it like we kind of demoed here, or is there an ability to integrate this stuff with Java-based applications? Like, can we get this integrated more tightly?
There is. So all of SQLcl is Java, as you know, and you can wrap that up in your application. So there is an API that literally is a one API call to call SQLcl with your set of changes and do whatever you like. So you can do that either. You could do it in Visual Studio Builder as well, because SQLcl is burned into that. But to answer Dan's question, you can run and integrate SQLcl into your application, and it will apply these changes in the same way, and all of the logs and things are generated in the same way. Again, SQLcl can be loaded, and I talked about it earlier about the availability of SQLcl and where it is. It's available in tons of places, and that means it should be available for install into your Docker machines or any of your machines that will allow you to build it into your pipelines as well. So that's the idea. If it's not in somewhere, I want to know about it, and we'll put something together.
We'll have to get some doc out to the public on how to do that type of integration. But at the end of the day, when you're starting up your Java app, the new version of it, you should be able to have hooks that just start Liquibase, it updates your schema and then continues booting the application.
Yes, not unlike what Micronaut does.
Exactly. Yep.
Today.
Precisely.
And just on the note of docs, the example that Neil and I went through, we're going to have that in the quick start guide. You just give us a few days and it should be up there shortly.
Okay, everyone, it is the top of the hour. So on that note, we might have to wrap things up. As always, thank you very much for you all as attendees to giving up your time. I can tell from the chat and from the Q&A that you're all pretty excited about this as much as we are. It's certainly going to transform the way from the hodgepodge, the myriad of ways people have been deploying stuff throughout the last probably decade. They've had all sorts of homegrown stuff and various solutions. We finally got an idea here which brings it all together and gives us a really robust and sort of thorough mechanism going forward that will continue to evolve. So thank you very much to the guys for joining the call. And we'll see you probably next month for normal general database office hours. As the guys have said, this session will be repeated, but with a more Apex slant in a couple of weeks for the Apex office hours. So if you're an Apex developer on the call, make sure you join that one to get the more Apex-centric view of the world here. But until then, thanks for joining General Database Office Hours as always. Thank you much to the guys. And we'll see you next month for another office hours. Thanks, everybody.